This house has two sets of stairs. That is a concept that we talked about a lot back in the design phase, and we got a lot of input from you guys. And some of the input was to put a bathroom under one side of this second set of stairs. Great suggestion, and that's where we're at today, is putting a set of winders in the end of this house between the kitchen and the garage, with one side of the stairs going right over the top of a half bath. Winders are different than the straight flight that you got to watch me put in and screw up on. I mean, remember that. They are different in that they turn halfway up the set. There's a couple of ways to make that winding action. You can make a series of walls which define the nose of the step at the increasing elevation, and then hang the back of the step off of the adjacent wall, which is taller by the amount of the rise. Or you can build a series of platforms. We're going to build platforms, one on top of the other, as we work our way around the corner of this set of winders. Several reasons. One of them is I've got a bunch of 2x8 left over from forming the footings on this place that will work great for the ledgers and the joists in these platforms on this set of winders. First of all, we need to think of this set of stairs as three separate components: two straight flights and one set of winders. A winder is any step or set of steps that is narrower at one end than at the other. They're used to change the direction of a flight of stairs and to squeeze more stairs into less space. For our stairs, we are changing directions 180 degrees right at the halfway point, with one of the straight flights going from the first floor to the winders and the other going from the winders up to the second floor. I have already measured and calculated the stair rise and tread widths off camera, and I drew it all out on the floor so I could really visualize it. In our next stair video, we'll really go through exactly how to calculate these things. But in general terms, you divide the rise, the total height between floors, by how many steps you have. You use that number to calculate the rise. Do the same thing with the horizontal distance to calculate the tread length, or the run. Stick with us in this house building series and you will get a detailed explanation of this process before too long. The first thing I am going to build is the winders themselves. The winders are being held up by the walls on one side and the column or post on the other. Think of these winders as a series of platforms, each one on top of the last. I need the first platform, the lowest one, to be at the exact right height. This ledger is being fastened on the wall 3/4 of an inch below the final elevation of the first winder step, because I'm using 3/4 inch decking for the treads. The other winders will be built on top of this, each platform the height of the next step. Even though the platforms are all fastened one on top of the other, they are all attached to the walls also, so all 4 winders are not entirely supported by just one platform. This post is important for a couple of reasons, the first of which I already mentioned. It's holding up the narrow end of each winder. It also defines how narrow the narrowest part of each step can be. For example, I could have put a piece of steel in here as the post to hold up each winder quite easily. The steel could have been very small in diameter or cross-section. The problem would be that these winders would come to almost a point at the inside, which is not safe. Think about it. There would be no place for your feet, for your foot, for a boot, just a toe or two if you're lucky. But you would still have to navigate the entire rise. It would feel very uncomfortable, it would be unsafe, and coincidentally, it would not pass inspection. Our building code is the minimum tread width of the winder is 6 inches at the narrowest point. I'm building this column from a 2x12, adding the thickness of the OSB sheeting to it, so each face can receive 2 winders, each a little more than 6 inches in width. You'll get a good look at this later on in case that was hard to follow. building a small wall that will hold up the ends of the stringers of the lower flight. It will not receive any sheetrock because it is below the stairs. The little wall at the other side of the winders will brace up the platforms where the other stairs will start and will be the sheetrocked wall behind the toilet and the half bath when the house is all done. The joists, 6 7/8 inches wide, and the decking, 3/4 of an inch thick, in each platform total 7 5/8 inches thick, which is the rise of each step in the entire set of stairs. To get the joist material to that size, I have to rip it down. A rip is a cut that runs parallel to the length of the board. Each platform is fastened to the wall and column and attached to the platform below it. It looks like a bit of a mess, doesn't it? All these layers of lumber and OSB stacked on top of each other. Some of the boards new, some of them form lumber. But that really just highlights one of the nice aspects of framing, and that is, nobody's ever going to see this when it's done. It needs to be strong, it needs to not squeak, it needs to be square, plumb, and true, and comply with the code. And that's it. If it looks a little unusual to the untrained eye, it's no problem at all. I'm not taking it to the fair. As is often the case, our house plans show what these stairs should look like once they are finished, but they don't tell me how to build them. A carpenter can be pretty creative in determining and solving some of the puzzles that show up on a set of house plans. There is a whole different way that these platforms could have been built, and that's with a system of pony walls, holding up each step. Imagine each winder having a short wall under the front, bringing it up to the proper height, with an attached ledger supporting the back of the step below it. If I had loads of extra 2x4 material, that might have been a good option. One of the perks of doing it this way is that I have maintained a bit of space underneath these winders that could possibly be recaptured later on for storage. Now that the winders are in, I know A, where the bottom straight flight is going to terminate, and B, where the top straight flight is going to originate. But since I don't have the opening framed into the second floor deck yet, I don't know where the top flight is going to end. So we're going to concentrate on this ground floor. And I'm using this really cool little square fence. A fellow sent me an email last night, Steve Ellis in Houston, Texas, sent me a series of fascinating emails. There's a lot I can learn from that guy, and I've started with this little old school framing square fence, which I can tell already beats the socks off of stair gauge sets for laying out stairs. You've just got to have a framing square to build stairs. A framing square has two parts that are relevant for us today: the body or blade and the tongue. One of these is used to measure the rise and the other for measuring the run. Draw out your steps very carefully. Sharpen your pencil and then double check your work. After you've double checked your work and been very careful with your lines, check it again. So getting to the key, to the thing that causes the most frustration for people the first time they're building a set of steps and are trying to figure out why their bottom step is so much taller than their top step, you subtract from the rise of your stringer the thickness of your tread. First rise only. In our case, we're using treads. We finally will be using treads that are 1 inch thick. So I'm going to subtract 1 inch from the bottom of our 7 5/8 inch rise. Think of it this way. When you're landing a straight flight onto your subfloor, the subfloor already has the tread on it, right? I mean, the tread is huge in all directions, but that's the elevation of the subfloor. The tread, the first tread that you're putting on your stringers, establishes the elevation of the first subfloor at the top of the first rise. So the heights of your subfloor, whether it's the first tread or the floor that you're landing on in your building, should match, which means that we subtract the thickness of the tread from the height of the first rise. Every part of measuring, marking, and cutting stairs needs to be precise. If the stringers don't match perfectly, or if your cuts are crooked, you're much more likely to have a squeaky set of stairs. Also, it can be dangerous if one step is a little taller or a little shorter than the others. It can cause tripping and stumbling over and over and over. Our building code stipulated that there should be no more than 3/8 of an inch difference between any two steps in the entire set of stairs. But even that's not ideal. Just go slow and cut slow and you can make them very close to perfect. Once you've got them cut, treat the stringers carefully because it is really easy to break off a riser if you're careless. I should mention here that the stairs we did on the other side of the house that you will get to see us replace pretty soon were really nice in this way. The stairs were all exactly the same height and everything fit nice, and they were great stairs. It was just that each rise was 1/8 of an inch taller than the 8-inch max that local code allows. And they were 1/2 an inch shorter than the 10-inch minimum that local code allows. I'm sort of glad to replace it, though, because the 7 5/8 inch rise that we're putting here and that we will put there is a little more comfortable to travel up and down. And after all, if a set of stairs are not comfortable, a lot of people are going to resent your decisions for a long time. One byproduct of me making that error on the other stairs is that I'm now real familiar with the fine print of our stair building code and stair building codes in other areas, and I don't think that I will ever make that mistake again. I prefer to pick the 2x12s that I'm going to use for stair stringers out of the stack myself instead of just hoping that something nice shows up on the delivery truck. There are several defects that a board can have that will not compromise a joist or a header at all, but will wreck a stair stringer. Things like excessive moisture, large knots, slope of grain, splits or pitch seams, among others, will really cut down the strength of your stringer and could cause failure. Now, sometimes you can lay out the cuts to get rid of some of the defects, and this is one good reason to buy boards a couple feet longer than you think you actually need. I like to attach a 1x to the outside of the two outside stringers. The 1x goes flat against the walls and creates a 3/4 inch gap between the wall and the stringer. What this does is save the drywallers a bunch of headache and a lot of time by not having to cut around and fit perfectly to each stair. They can simply drop a sheet that has a long straight angle cut down into the gap between the stringers and the studs and save themselves a lot of time and get a much cleaner look. When you're putting these stairs together, fasten the tops and bottoms with some hangers. Some joist hangers and some A35s and whatever other framing hardware you have available that your engineer specifies or that you think will help. And then slowly move through gluing and nailing or screwing if you want, and really fastening the treads and riser faces thoroughly. If you measured correctly, the rise between your first flight and the first winder should be the exact same distance as every other step. Well, these stairs are just about done. I've got to throw some screws in these treads, but the bottom flight and the winders, they're built, they're complete. The rise and the run is established and is code compliant, and that's good. We've got one little straight flight at the top. It has one fewer steps in it than this bottom flight does. It's nice to have this stairway in, because when you're plating, when we start plating and doing these walls upstairs, access is important, and we'll put a little railing around it so nobody falls in, but you know, stairs are a milestone, and we've just about got this taken care of. The last piece of this set of stairs is the small flight from the winders up to the second floor. Before we do that, however, I have a little more work to do on the decking, the floor system upstairs. I've got to get the floor all caught up so I can determine and be certain that I know exactly where that last set of stairs needs to finish, where it will attach, how it will attach, and that each one of the rises and runs will be identical to every other one in the whole set. We'll do that in our next episode. Thanks for watching, and keep up the good work.